Good evening, all of you. Welcome, you guys. Welcome you all. First of all, do check the audio video is clear or not. First of all, everybody, please check the audio video. Is it audible to all of you clearly? Right. Fine. So let's start our discussions, all of you. And before this, we have a small announcement from Unacademy. So we are starting a new series. We are starting the series called the Pado Kilo series. We are starting a new series, the Pado Kilo Crack Karo. So by playing, we can learn the concept and you can crack the gate. So the series we have started from the July 1st to August 15th. And for EC and electrical engineers, we have started with the top educators. We'll take the classes with the in detail concept they are going to discuss. Right. And the other special classes we have with the features of special classes are live interaction with the educators, polls we can conduct, raise the hand options. You will never miss a class. You will get a regular notification from Unacademy, lecture notes, and anytime, anywhere you can access. And tomorrow we have a same timing, 7 p.m. We have a special class. Tomorrow, same timing, 7 p.m. We have a special class in Unacademy platform. So you can do follow me. You can follow me, B V Reddy. Link given in the descriptions. Link given in the description. You can enroll for it. Right? And so we are conducting a daily scholarship test so that you can utilize this opportunity to crack it. Daily scholarship, you just log in with your number, click on the start learning and select your goals, EC, electrical, civil, mechanical, whichever the goal you selected, and then start writing the tests. And these are the new batches we are starting. You can see I'm started the from 29th onwards. I'm started the digital. I have started, and from the July 13th onwards, I'm starting the signals. I'm starting from July 13th onwards. I'm starting the signals. You can follow this course, and you can find the top indicators. You can find in the single frame. And these are the new batches we are running for GATE and ESE 2023-2024. And the target GATE and ESE batch for the top educators of India you can find. And the ESE batch for 2023-2024, you can see the top educators. And with the Unacademy, you will get the plus subscription, you will get the top educators who will take the classes, doubt solving sessions, study notes, and test series. And for the iconic students, in addition to plus benefits, you will get additional benefits of physical notes. Right, so one-to-one mentorship, strategy and study program, and live interaction with the educators. Right. Why many GATE educators left Unacademy? So here, that is their personal issue. Yeah, so we should not comment about those things, isn't it? As you know here, that is their personal. So here we cannot ask why they joined in Unacademy and why they left Unacademy. So that is their personal issues, isn't it? So that is their wish. So that is a personal now. So if I like the job, we'll continue. If I don't like the job, I will leave simply. We have an option to go anywhere now. So we have for constitution given, so right to work. The only thing is we need to properly complete the formalities and we can leave. If I don't like any so and so, I can leave it. That depends upon the personal. Might be so they may not be satisfied with this. They left. We cannot. So here, this thing that is their personal. So We cannot talk. So even if you join any company, let us say, if you like, you can continue. If you don't like, you can leave. That's all. And so you can take the Unacademy subscription with a zero extra fee, additional fee. So you no need to pay any additional charges by taking the Unacademy subscription with the EMI. Without paying any additional charges, you can get it. And the students who are willing for Unacademy subscription, they can use the code of BVReady to get my personalized guidance and to get the DPPs and complete full notes and the material you can get from here. Right? Today, let's start our discussion, all of you. How many problems we have completed previously, you can see. How many problems we have completed previously. Many problems we have finished, you can see 100. Yes, very good. We have completed 100 problems. We have completed. हमने century complete किया, isn't it? So here century complete किया. So I hope all of you are getting the confidence with this transients. I hope you fellows are getting the confidence with the transient, isn't it? One zero two completed. 100 completed. 102 here. 100 completed. Right? And tomorrow we have special class. Tomorrow we have special class. Okay. Tomorrow we have a special class. So same timing 7 p.m. Okay. Tomorrow we have special class at 7 p.m. Right? Yeah. So don't worry. So totally in the transient we have a 350 problems are there. So 350 to 400 problems we'll solve on the transients. Okay. And tomorrow, so here theorems completed. In the special classes, we completed the theorem series completed. Anything left? Theorems completed, I think so. Isn't it? If the theorems completed, then we can start AC circuits. If the theorems completed, then we start AC circuits. We can start. Okay. Some questions left. Okay, then okay. Then whatever the things we have left out here, so you can ask. And tomorrow onwards, we start the AC circuits. What you will say? Tomorrow special class will start the AC circuits. In the YouTube class, we'll do it as transient and AC circuits in the special classes. Okay, let's take the problem, all of you. Let's take the first one, 101. 101. So हमने successfully century complete किया. Then I hope you fellows are getting the confidence slowly. So then by end of this, our triple century, you will feel fellows definitely will get a lot of confidence. Don't worry. Right. Take the next problem. The capacitor shown in the figure is initially charged to 10 volts. The switch closes at t is equal to 0, then the value of Vc of t in volts at t is equal to 10 milliseconds is, right. And capacitor has initial voltage of 10 volts. Initially the capacitor has a 10 volts at before closing the switch. They are asking to find the Vc of t. So let's find here Vc of 0 minus, which is given as 10 volts, right? Now what they are asking here, the value of Vc of t at t is equal to 0 plus. That means, can you tell me Vc of infinity? Vc of infinity, we can say 0. Check it. Why? Because, so this is source free circuit. Now tell me. Why? Because which is a source free circuit? Now tell me tau. Tau equal to RC. So it is 10k, 10 into 10 cube into 1 micro, 10 power minus 6. So tau equal to 100. Done? Then tell me now here. So what is the expression for the current VC of t now here? Is equal initial value 10 into e power minus t by tau. So here t by 100. So replace now here we need at 10 milliseconds we need. So tell me now here VC of t at t is equal to 10 milliseconds. 10 into 10 power minus 3 is equal to 10 into e power minus of 10 into 10 power minus 3 by 100. So how much is value? If I tell me which is equal to 3.678. Done? Okay, sorry. Okay, 1 by 100 now. I mean to say this is 1 by 100. So this means 100t. This is 100 into 10 into 10 power minus 3. 1 by 100. Yeah. Fine. So how much is value? 3.678. Chalo, next problem. In the circuit shown in the figure, the value of capacitor needed to have critically damped response. In the circuit shown in the figure, the value of capacitor needed to have critically damped response. Critically damped response. It is a series circuit, now tell me. But critically damping, so how much the zeta value must be? Zeta must be equal to 1. Series circuit now here, RLC series circuit. For the series RLC circuit, did you remember the zeta value? Zeta which is given as R by 2 into square root of C by L. Isn't it? So this zeta value which is equal to 1. Simplify it now here. Get the value of C. How much the C value will get, tell me? 10 millifarads. Yeah, we did some problems in the class, even though we'll repeat the problem. Okay, it's just a practice session now. It's just a practice session, right? So here you should get the confidence to solve the problems. Next, in the figure shown, ideal switch has been open for a long time. If it is closed at t is equal to 0, then the magnitude of current of 4K resistor is. What here? Which one? Here they are saying this as the critically damped response. So here saying that this capacitor has an initial voltage of V0. Capacitor has an initial voltage of V0. Did you remember this thing here? If you say that is equivalent circuit, I can replace this as an equivalent circuit as like this. Right. So this is 40 and this is 4H and C and this is the V naught. So if I say here, okay, this current, so we'll take the current this direction. This is my I of t. So what we can say now, if we write the KVL in the loop now here, what we'll get now here, this V naught, which is equal to 1 by C integral of I into dt plus 4 into di by dt plus 40 into t, 40 into I of t. Now if I differentiate on both sides, then what happens, you tell me? Which will get it as a 0, we can get it up now? Here, which is equal to 0, which is equal to, this is I by C plus 4 into d square by dt square. D square I by dt square plus 40 into di by dt. Now we'll convert into Laplace. Now if we convert into Laplace, so then what happened to this equation now, tell me? Which is equal to this 4. So which will become s square into I of s plus 40 s into I of s plus 1 by c into I of s, which is equal to 0. This is the expression, we'll get it now here. So s square plus 40s now here. From this we can get it as zeta value. So this is the second order system. S square plus 40s plus 1 by c equal to 0. From this equation we need to get the zeta. So this series circuit will get the zeta as a r by 2 into square root of c by l. Okay. So this value, whenever they mention this type, so this is what now here, initial value of a capacitor. If it is inductor has initial value, they will mention like this. This is inductor initial value. Initial values can be simply upper, they will put the arrow or terminals they will give. Then all of you, in the given figure, the ideal switch was open for a long time, and if it is closed at t is equal to 0, then the magnitude of the current through 4K resistor is, ideal switch has been open for a long time. It has been open for a long time and it is closed at t is equal to 0. Means at t equal to 0 minus switch has been closed. Now tell me, t is equal to 0 minus switch is open. So that means redraw the circuit now, steady state. Redraw the circuit. So this is 10 volts. This is 5K. And which is 4K. And this is 1K. And this value, which we can say is as Vc of 0 minus. This current is IL of 0 minus. Tell me now here how much is IL of 0 minus is equal to 1. Is equal to 1 millina. Then Vc of 0 minus. How much, which is equal to 5. Now he is asking at t is equal to 0 minus, he is asking to find the current. T is equal to 0 plus. Now tell me now t is equal to 0 plus, what will be the comma the current, you tell me? Now capacitor, which is a short circuit with the initial value. Which the scenario. Inductor is open circuit with the initial current now. This is 10 and this is 5K and this is 4K. This is 5 volts and here this is 1K and this current, how much is value? 1 milli. Now we need the current where now here? Here we need this current. This current is required. Tell me now here. Now how much is current now here? So in this loop there is a flow of current is now this current. So what is this current here? How much we can say here? Which is equal to 5 by 4K. Check it all of you. Is equal to 1.25 milli. Okay. Next one. Where the next problem? In the figure shown, the capacitor is initially uncharged. Which are the following expressions describes the current I of t? Okay, so capacitor, so can you tell me initial values now here? Initially uncharged already given. So that means Vc of 0 minus, which is equal to 0, and Vc of infinity, how much you can say? Which is equal to 2 by 3 into 5. Check it. So which is equal to 10 by 3 volts. Can you tell me the tau? Tau is equal to, these two are parallel. So here that is 2 by 3 into 10 cube into 10 power minus 6. So that is tau is equal to 2 by 3 into 10 power minus 3. Okay, milli. So all these options given 5. So we'll get the Vc of t, which is equal to, so that is 10 by 3 minus 10 by 3 into e power minus t by tau. Right. Now tell me now here IC, C into dV by dt. C into dV by dt. I equal to C into dV by dt. C value how much now here? Micro. So this is now 10 power minus 6 into, this is 10 by 3 1 by tau, isn't it? Into e power minus t by tau. What's the option you tell me? कौन सा ऑप्शन होगा? Can see tau simplify, get it. कौन सा option now here? Option A. Asking to find I of t current here. Okay, this current he is asking to find. Need of IC of t now here. Need of IC of t. Right. They are asking to find I. So this voltage is same as this voltage. So then I of t. Okay, not IC, they are asking to find. So that means what we'll get now here? 5 by 3 into 1 minus e power minus t by tau. Right? A series RC circuit connected to a DC source, DC voltage source at T is equal to 0. The relation between the voltage source and the resistance R, capacitance C, and the current I of T given below like this. Okay. So instead of giving the circuit, he given this relation is given. Okay, can you develop the circuit for it? You tell me. You can develop some circuit now here. Hmm. So this circuit is given as like this. That is at T is equal to 0, switch has been closed. At T is equal to 0, switch has been closed. Right? Now simplify it. Now this is the circuit they given here. AC of T, VS is which is given. Now tell me now here. VC of 0 minus. How much the VC of 0 minus is equal to 0. VC of infinity. How much the VC of infinity you tell me? Which is equal to Vs. And tau. Tau is equal to RC, right? Tau equal to RC. Now we need what we need here? We need RC.